Welcome to this GCSE Physics revision on magnetism and electromagnetism. In this lesson, we will explore the fundamental concepts from magnetic poles to transformers. Foundations of magnetism. Magnetism is a physical phenomenon produced by moving electric charges and intrinsic particle spins, governed by magnetic fields that exert attractive or repulsive forces on objects. Magnets always have two poles, called the north and south poles. Like poles repel each other, while opposite poles attract. It's impossible to have a magnet with only one pole. Magnets are divided into permanent magnets and induced magnets, which differ by how they produce magnetic fields, whether they can repel, and how long their magnetism lasts. A magnetic field is a vector field near a magnet, electric current, or changing electric field where magnetic forces can be observed. Magnetic fields surround magnets and can exert forces on magnetic materials. Field lines represent these forces, moving from the north to the south pole. The closer the lines, the stronger the magnetic field. To plot a magnetic field using a plotting compass, follow these key steps: place a bar magnet on paper, position the compass near a pole to mark dot positions, and connect the dots to map the lines. Earth's magnetic field is an invisible protective force field generated by swirling liquid iron and nickel in the planet's outer core, guiding compass needles and shielding life from solar wind. Fleming's left-hand rule helps us predict the direction of force on a wire carrying current in a magnetic field. Your thumb shows force direction, your first finger the magnetic field, and your second finger the current. When electric current flows through a wire, it creates a magnetic field around it. This field forms circular lines around the wire, and its strength increases with more current or closer distance. When a conductor moves through a magnetic field, it cuts through magnetic lines of force, generating an induced voltage. This process is called electromagnetic induction. Electric motors turn electrical energy into movement. When current flows through a coil inside a magnetic field, forces push the coil to rotate continuously, creating mechanical energy. Electromagnetic induction is the process of producing a voltage and electric current in a closed circuit through a changing magnetic field or motion. Discovered by Michael Faraday in 1831, it serves as the core principle behind electric generators, transformers, and motors. Loudspeakers work by changing electrical signals into sound. A coil attached to a cone moves back and forth in a magnetic field as current changes, causing the cone to vibrate and produce sound. The generator effect converts mechanical energy into electrical energy by rotating coils in magnetic fields. This principle is used in power stations, bicycle dynamos, and hand-crank torches. Microphones change sound waves into electrical signals. Sound causes a diaphragm to vibrate, moving a coil in a magnetic field and inducing a voltage that matches the sound's pattern. Power transmission is the bulk movement of energy from a generating site to an electrical substation, utilizing key components such as high-voltage lines, transformers, and substations. Transformers adjust the voltage of alternating current. They have two coils wrapped around an iron core. By changing the number of turns in these coils, transformers can increase or decrease voltage. The national grid reduces energy loss by using step-up transformers, high-voltage cables, and step-down transformers to lower current and minimize heat waste. In summary, magnets have poles and magnetic fields. Electric currents generate magnetic fields, enabling electromagnetism. Fleming's left-hand rule helps us understand forces in these fields. These principles power devices like motors, loudspeakers, generators, microphones, and transformers.